Okay, we'll be looking at the effect of changes in pH to the enzymatic reaction. Right, so enzymes work within a very narrow range of pH, and if the pH is changed beyond this range, the enzymes would be denatured, right? Because the hydrogen and ionic bonds are disrupted by the change in the number or concentration of H+. Okay, and if the change in pH is large, the enzyme might even precipitate out because of the high nature of denaturation. The enzyme would not be soluble anymore when it is not properly folded, and therefore they becomes PPT lah. So if you look at the shape of the pH graph, right, it is usually more narrow than the temperature graph, and it's more of a parabola, right, if you compare it to the temperature graph. So remember that the temperature graph, right, the denaturation, when the temperature is high beyond the optimal, the decrease is more drastic, right, than the increase. So for the temperature graph, it's less of a parabola, it's a bit more skewed. But for the pH graph, it is more of a parabola. Right, so let's start off with the optimum pH. Right, this is the pH at which the rate of reaction is at its maximum. Right, this is the pH in which the enzyme has the correct specific 3D conformation, the shape of the enzyme, and therefore the shape of the active site is maintained. And because of that, there is effective collision and formation of enzyme substrate complex. So therefore the rate of reaction is at its maximum. But when the pH deviates, right, from the optimum, the change in the concentration of H+ would disrupt the hydrogen and ionic bonds between the R groups in the enzyme molecule, and that brings about the denaturation of the enzyme. And with that, there would be the lack of maintenance of the shape of the enzyme, which in turn causes the loss of the shape of the active site. Besides the change in the shape of the active site, right, for certain substrates which are charged, and therefore the enzyme should have a complementary charge at the active site, the change in the concentration of H+ as the pH changes would also cause a change in the charges of the active site and the substrate. So besides the loss of a complementary shape, there may also be a loss of complementary charges. So together, right, this will prevent the binding of the substrate to the active site, and therefore lowering the rate of enzyme substrate complex formation, lowering the rate of reaction. Right, so a picture here, right, describes the change in the charge of the active site. Okay, so the substrate is positively charged, and therefore the active site carries a complementary negative charge, and therefore the substrate and enzyme are able to bind, right, to form the enzyme substrate complex. But when the pH decreases, when there is a higher concentration of H+, the H+ can neutralize the negative charge at the active site, and that would inhibits, or rather not inhibits, that would lowers the likelihood of binding between the substrate and the enzyme, thus lowering the rate of effective collision, enzyme substrate complex formation, and rate of reaction. And this is without considering the change in the shape of the active site, because the picture only shows you the change in the charge. Right, so coupled with the change in the shape of the active site due to denaturation, that would bring about a very sharp decrease, and therefore explaining why the curve for the pH graph is usually more narrow. Alright? Okay, so just a bit more. If you compare the explanation, right, for the effect of temperature versus the effect of pH, for the effect of temperature, we start off with the low temperature. Then we talk about the increase all the way to optimum, and then we talk about increase beyond the optimum. Right? Reason why is because before the optimum temperature is reached versus after the optimum temperature is reached and it increases beyond the optimum temperature, the effect of this increasing temperature on the enzyme is different, right? Before the optimal temperature and after the optimal temperature. That's why the explanation starts off with the low temperature, then we talk about how increasing temperature affects the enzyme until the optimum, and then a different effect beyond the optimum. But for the pH, the effect of a lower pH or a higher pH is rather similar in terms of concept. Of course, the specific change in the charge of the active site will be different, right? Because one is with more H plus, the other one is with more OH minus. But effectively, right, the explanation is similar, right? Whether it is low pH or high pH. That's why for explanation of the pH, we usually start with the optimum pH, and then we just mention a deviation, right, from the optimum, whether it is higher or lower. Okay, the explanation is rather similar. Okay, so we don't really start with the low pH, then optimum, then high pH, because if you do that, you'll be repeating yourself. Right? When you do the low pH and then you do the high pH, the explanations are similar. Right? So that's why the explanation in the notes and also in this recording, right, it's a bit different. The sequence is different. Okay, so do take note of that. That might help you in your answers when you are doing the explanation, right, for the temperature and pH. Okay.